Hi guys, we'll move to the question number 5. In the question number 5, there are a lot of things we want to clearly identify. The first one is the notation. These notations we want to carefully identify. And the meaning of what is logically equivalence, that also we want to understand. I'll first draw these things and I'll explain the things. The first it says like this. What is this arrow means? P implies, this arrow means implies. P implies R. And what does this notation means? It is and. This is and notation. And where P implies R and Q implies R. Okay, that is the first statement. Okay, they are telling this is the first statement and this is the second statement. So I'll take this first statement as A, and the second statement I will take P and Q implies R. This is the statement number B. Okay, so what do you mean by logically equivalence? Now, since for the simplicity, I will take this statement as A and the second statement as B. Logically equivalence we can denote by these three lines. A logically equivalent to A statement, logically equivalent to B. Okay, that means, guys, that means when you draw the truth table for this each condition, okay, each condition, if you draw the truth table, you should get the same value for all the rows. Okay, that means in the truth table, all rows you will be getting the same value, means that is logically equivalent. But even one is different, that means those are not logically equivalent. In order to satisfy the logical equivalence, all the rows in the truth table, you have to have the same value. Even one is different, that is violating the logical equivalence. So A and B are logical equivalence means we should get the same truth value for all rows. Even one is different, A and B are not logically equivalent. Okay, A and B are not logically equivalent. That is the basic thing we want to understand. Logically equivalent means you want to have the same truth value for all rows. Okay, now how do you check whether we are getting the same truth value? So first of all, you want to identify how many variables here. Okay, in this case, how many variables? P is one variable and Q is another variable and R is another variable. Here there are only three variables are available. If there are three variables are available, you are getting the number of rows by 2 to the power 3, that is 8. If there are four variables like PQRS, you are getting it is 2 to the power 4, it is 16. If there are 5 to the power 5, that is 32. But in our case, it is 2 to the power 3 because there are only three variables are available. Okay, then we'll erase the things and we'll draw by using a ruler. What we can do is, right guys, we'll remove the rule now. We'll put the variables. This is the P and here Q and here R, and here we'll put this P implies R, and after that we'll put this Q implies R, and after that we'll join these two, that means P implies R and Q implies R. It is the A, okay, A, statement A, and after that P and Q, and here P and Q implies R. Okay, and we'll delete this part because I want to have this area. Right. Okay, now we have drawn the truth table variables, and the most important thing is we want to identify what do you mean by this imply. What do you mean by this imply means simply, okay, simply if something happen, what, how do you keep the promise or not? As an example, we'll take a basic example. uh, if it rains today, I will bring an umbrella. I will bring an umbrella. So this is our the first variable P. Okay, this is our second variable. It is Q. Okay, now this if P is true only, I will keep my promise. Okay, if P is true only, I will keep my promise. Okay, so if we write like this, say P and Q, and P implies Q. Okay, if I bring an umbrella, sorry, if it rains today, I will bring an umbrella. That means this also true. Okay, these two are true. So I will keep my promise, because if it rains today, I will bring an umbrella. Okay, what will happen if it rains today? I will not bring an umbrella. Okay, if it rains today, what happened if I do not bring an umbrella? That means this is false. This false means I am violating the rule. I am violating the rule, because if it rains today, I promise that I will bring an umbrella. But what I have done, I didn't bring an umbrella. That means it is violating the rule. That means it is false. Okay. Tell me this one. If it doesn't rain today, that means this is false. What will happen if I bring an umbrella? That doesn't violate the rule, right? Okay, I have to bring the umbrella when it rains. But even though it doesn't rain, if I bring an umbrella, mean it doesn't violate the rule. So this is true. Okay, if it violates, if that will be false. If it doesn't violate, if it is true, then it is true. So what will happen if it doesn't rain today? What will happen if I didn't bring an umbrella? Still it is not violating the rule, right? Because I have to bring the umbrella when it rains only. Here it doesn't rain today. I didn't bring the umbrella as well. So this is true. So only the violating condition is if the first one is true, the second one becomes false, then it is violating. All the other cases, it is true. You can see that this is true, this is true. So the P is true, Q also true, then it is keeping the promise. If the P is true, Q is false, then it is violating, then it is false. If P is false, Q also false, then still it is not violating. P is false, Q is true, still not violating. So only the violating condition is P is true and Q is false. Okay, so that is the basic thing you want to understand. Okay, now I erase that thing as well. So you want to get that idea there. Okay, now since these are 2 to the power 3, it is 8. So 8 means the first column we want to have force of T, T4. T, 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 T4 and F4. That is the way we are writing. If it is 16, we are writing 8 of T's and 8 of 4's. And the second column, half of this one. Now here T4's are there, now here 2 T's, and after that FF, TTFF, again TTFF. And the third, how do you write? TF, 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 TF. That is the way we are writing. Okay. Now P implies R. Now you know that P implies R means only the violating condition happens if P is true and R is false. Okay. All the others are true. Okay. So now P is true and R is true, then it is true. Okay. P is true, R is false, then it is false. Okay. P is true, R is true, it is true. P is true, R is false, again false. P is F, false, and true, it is true. False, false, also true. False, true, also true. False, false, also true. Now Q and R. Q implies R. Here T, 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 TF, F. FT true, FF true, TT true, TF false, FT true, FF true. Okay, now by combining these two, combining and condition is only valid, both are true. Both are true, here false, true, false, true, false, true, 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 false, true, false, true, false, true. And here P and Q, P and Q, you want to consider P and Q, both are true, true. Okay, true. One is false, false. 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 And this one, P and Q. Now consider this is the first one. Okay, this is the first one, and R. The first one is true. P and Q. P and Q is true, and R. P and Q are true, true, true. True, false, false. False, true, true. False, true, true. False, false, true. False, true, true. False, false, true. False, false, true, true. False, false, true. Okay. Now consider this A is here, this is B, and check all the rows of A and B. Check whether both are getting the same answers. You can see here true, here also true. Now this means the first one is true, right? That is correct, getting the same answer. And here false, and here also false. That also you are getting the same answer. And here true, and also here true, you are getting it also the correct. But check with the fourth. False here, A is false and B is true. So this is violating. The fifth one true, and here also true, that is correct. Sixth one false and here true, this is violating. Seventh, that is true, both here also true. That means you can say that row number 4, here row number 4 and row number 6, you are getting two different answers. Therefore, you can say that A and B are not logically equivalent. The reason is, even one is getting different, you can't say that it is logically equivalent. So you have to ultimately say that what you want to say. You want to say that these are not logically equivalent. The reason is we are getting the two different answers. Okay, 4 and 6 we are getting different answers. So at the end we can write P implies R and Q implies R. This is not logically equivalent to P Q implies R. The reason is what? Row number 4 and row number 6 getting different truth values. Okay, that's the end of this logical equivalence.